dictionary. We'll continue with dictionary, what we have done so far. And we said that dictionary is made of key value pairs, and they are unordered, and they are definitely mutable. And so far, we have looked at so many operations on them. So I'll be sharing my screen shortly. I'll go straight to what we have done. You can see here. So we've looked at how the last class we had was adding elements to a dictionary, and the next thing we're going to look at is how can we then delete elements from a dictionary. Sorry. So we have certain methods that we do. In list, we use the pop and also the Dell method. And also we in dictionary we also use that as well. So it actually returns the deleted elements as POP, the pop method that we use for the list. And let's see what I'm doing here. Numbers underscore names is equals to an empty dictionary. Remember, a dictionary is being represented by curly brackets. And by the time you get this done, name number underscore names, you are trying to populate the dictionary. That means you want to add to that this particular empty dictionary. You can see how we add them. So we added the one here is equals to 1. So by the time we get all these values, you can see this is a key and these are the values that we are adding to this particular key. So by the time we call out the number underscore name, which was initially empty here, we have what we call a list, a dictionary that has one, and as well. Okay, so just excuse me for a minute, seconds. Oh, sorry about that. I had a call. So we have 1, 2, 3, 4, 5, 6, 7, 8, and that is representing 1 to 8, like in figures. So the key here is one is in words, and the values here we have here is definitely in figures. So by the time we delete this, how do we use the pop method in dictionary? So we call out we allocate a new variable to it, that's deleted underscore element equals to the name of the dictionary in which you want to delete from, and dot pop. And what are we putting pop in list? We're supposed to have put the index here, but in dictionary we are putting the key of that particular dictionary, which is we would want to delete the eight, this particular eight here. So we do what we call out the key, which is 8, and by the time we call out the number underscore names, it doesn't contain uh, the 8 anymore. It has been deleted because of what we have done. So by the time we do the same thing for 7, it does the same thing. It's deleted as well, and the same thing as well. So by the time we use another, like for example here, we are naming it, we're putting it in a variable as we did before. We're putting in a variable, and by the time we call out the deleted element, is going to do what? Return the only element that is still inside the deleted element, which is 4 here, which we have done on this particular line. So by the time you also call out the number underscore name, the main dictionary itself, it will not contain 4 again. It is going to remove that as well. So far, we have removed 7, we have removed 8, and also we have removed 4. So if you call out the number underscore names, it will not contain those key value pairs anymore. So I think that should be done for pop, which we have done already for the list operations as well. So we go straight to the Dell method. Uh, this one doesn't return the element at all, unlike before that we do for pop. When we call out the deleted element, it's going to return the deleted element, which we have already defined in a variable. But in this one, is quite different, and we can see it here as well. So we can say Now look at what I've done here. I've done something different here. Unlike the other one here I did here, guys, please pay attention. Number underscore names equals to a curly bracket, which was an empty dictionary from the very beginning. But look at what I've done here. There are other ways of defining dictionary. So I did number underscore names equals to DICT, DICT, and in brackets, the normal parentheses that we have here. This is also defining an empty dictionary. It's exactly as the other one, just that I'm putting it as what did and open and close bracket, normal parentheses. I know at some point, Dr. Pemi, why don't you just use the other way, this one that we have that is very easy? It's always a way of maybe trying to see there are ways you can actually go around. If someone might actually like this method, other person might like another kind of method as well. So we continue like that. We populate the dictionary. By the time we call it out, it does almost the same thing here. So how do we delete it? We just put the delete, a DEL method here, and put the name of the dictionary, and we put the key, not the value. If you put one here, if you put one here, it will not work like the normal figure of one. It will not return anything because that's not the key. It must access the value of a particular dictionary by using its key. Okay. So by the time you call out the number underscore names, you can see that one will no longer be in that particular dictionary. The same with other ones, and so forth. We decided to delete 5. There we call out the dictionary name number underscore names, put it the 5, and if you check it again, 5 do not exist in this dictionary anymore. Okay, so what if we pass a key that does not exist in the dictionary? If you pass it up, it's going to give us what? A key error. It will tell you that it will not what? It doesn't have the what? The particular key of 10. So the key error here, 10 doesn't what exist because in original dictionary, there was no value or key that has what 10. Okay, so that's how we roll in that particular concept of deleting elements from a particular dictionary. I would like to stop here and ask questions. If you have questions at all at this particular stage, you can actually ask. If you have any questions, or should I go ahead, please? It's very important. Should I go ahead? Please confirm I should go ahead. You can give me a signal I should go
I
ahead.
can't see your screen very well. I can't see your screen. If it's network. Anyway, let me log out and log in.
Okay, please let any other person confirm. Can you see my screen? Mr. Funso, Dr. Pemi, Dr. Solomon?
Yes, I can see it.
Okay, all right. Okay. Okay, I think it's a network problem. Okay, someone say go ahead. Okay, can see I can go ahead. Okay, so let's see how we can actually. I think Nena is trying to get back in. Let's see. Okay, so the next thing we're going to look at, how can we read elements from a dictionary? How can we read elements from a dictionary? We're still doing the same thing here. We're populating it as well, and how can we read elements in a dictionary? For example, you want to access the value of maybe, let's say, we have the dictionary here 1, 2, 3 to 8. What we want to get the figure of 7 here, how do we do that? We just call out the name of the dictionary, put it in a square bracket, and call out the key, and you definitely have 7. And the same thing for 2 and the rest. And also, there's what we call the items. Please, guys, pay attention. It's going to be very important. We will actually use these items, and there will be other methods that we're going to use to assess. When you want to look through a dictionary, these are the things we are actually going to be needing in looping through our dictionaries, and you can't just look through dictionary just like that. There are procedures in which you do, and for you to get the for that, you have to access it through the items kind of way. And when you say dot items, it brings all of them out and put them in a tuple kind of way. And tuple means it's going to give you in a parenthesis, that has that parenthesis, the normal bracket that we know is going to put in the key and the values inside a particular parenthesis. If you can see the output here, uh, if you call number underscore names dot items and you call it out, it's going to return the output of, you can see here, one, comma, figure one, two, comma, figure two. All of them are put inside a particular word, a parenthesis, which is known as the tuple. We are still going to get there, tuple as well. So you can see the results. It brings each of them out in groups. So you can see each of the key value pairs comes in groups and pairs. Okay. The other thing is, the other one we're going to look at is the dot keys. This particular one returns only the keys. That means, for example, it's going to return only the words, which is 1, 2, 3 till we get to 8. By the time you call out the name of the dictionary names, number underscore names dot keys. By the time you bring it, you can see it's going to bring out only the word, the keys of this particular dictionary. The same with dit dot values, return the values only. You can see it only returns the values of this particular uh, list. So let's see how we can make this possible. How can we now look through certain things with for loop? We want to print the items of this particular list. Please pay for this particular dictionary. Please pay attention. This concept might actually get a whole tricky when you get there. So unlike the other one that we do for list, we can just say for this in a particular, you put in the name of the list. I want you to look through it. But this particular one is quite different. So what are we using? For key, comma value, that is the name of the dictionary, dot items. Without these dot items, you will not be able to look through a particular dictionary. Okay, so we now said, okay, what are we doing? We want it to print the what, the key and also the values. And how do you want it to be printed? We want it to be separated by a column, and you can see here you're putting a comma here, putting a column here, and also the value here. That means the key will go for keys, and value will also go for value. We could have also decided to use, it may not necessarily be keys, oh guys, it may not necessarily be keys, but as far as there's a comma, you can put I, comma, you can say J here. There's no problem, but it's just trying to indicate that this particular, the first one is the key and the other one is the value. You can also reference this as I and also reference this as J. But I just want to remember when we said that anything that we do in coding should be descriptive enough. So we are trying to make it descriptive. If you go through tutorials, maybe search on Google, some part them you can see something like for I, comma J, in this the same thing. We're just trying to make it more understandable enough. So we get to this, and by the time we print this out, you can see it's going to come out exactly as we want it in the print statement here. And you can see one is column one, the same thing till we get to 8. So that's exactly what how to look through a dictionary using the dot items method. So the same thing, I remember what I just told you now. I just said you can also do the same thing. So I can say I'm now using K, comma V in number underscore names dot items, print K, comma, you do this, comma V. So by the time you make this work, it's still the same thing as you have in this other one. Okay. So how can we now say we want to look through only keys? Okay, I'm looking at my battery here, but nevertheless, there's always a way out. So once I get logged out, I will definitely come back in again. So don't worry about that. So let's continue. So only the keys. So how can we go through only the keys? So you can say for K in number underscore names dot keys. So what are we doing? We just print the keys. It's very simple enough. Print the keys, and that key was represented as K here. And by the time we do that, 1, 2, 3, 4, 5, 6, 7, 8, we do that. And before that, I would like to, before we do that, before I go into the next one, only the values. Let's see how you can come up with only the values. How can we print only the values? How can we print only the values? Let's see how we can make that possible. I've done for keys, I've done for items. How can we print only the values? It's very important. How can we get only the values? Okay. Okay. Please come up with something. How can we print only the values? Please, I need you guys to try something. How can we print a dictionary values only? You are permitted to check Google at any point in time. Okay. We're going to confirm this. I'm seeing some answers already here. So let's see. We're going to confirm if that's going to be true. So please bring in your answers. Your answers should still come in. Okay, I've seen two answers here already. And let's see what if it's gonna be true and nobody else is typing again. So let's see how true is this and let's work with that. Okay. So let's go straight to what we have. So it's actually what they did. Well done. Thank you, Miss Dr. Opeyemi and Mr. Sunday. Thank you very much. It's actually true. It's actually wonderful what you have done and it's actually true. So you can see it brings out only the values itself. So let's go to another kind of dictionary. Remember when I said that dictionary more like stores things like a database kind of system. It works well, and when you get to data science, you see a whole lot of concepts of dictionary. By the time you do, you do not change it to data frames, and you now put it in a tabular form. So most times you always use the dictionary to make that possible. So you can see here, we have the name and the key and the values. We have brand. We have this is a car. We have brand. We have Ford. We have model Mustang, year 1964, color red, and the rest. And we keep on going and going. So if you want to assess the brand of this particular thing, just call it out and make sure that it's always what in terms of what in the it's case sensitive. So you can see here, if you call out the brand, it brings out Ford. But if you call out brand in capital letters, it's going to give you an error because there is nothing like brand here when it comes to all capitalized. It's not going to happen. Okay. So so the next thing we're going to look at is the get, and you can also use the get instead of just putting it as a square bracket. You can use the get method here. You can just say car.get, and what are we getting? We want to get the brand of that particular dictionary in elements of things inside that dictionary of car. By the time we do the dot get brand, it's going to bring in the Ford. And if we do the same thing for uh, car.get brand, what do you think will be the outcome of it? What do you think will be the outcome of that? What do you think will be the outcome of that? So let me initialize this and let me run this from this cell. So this is running perfectly. Call out the car running. I call out this. Definitely is going to give us an error, but I want to run from here. It gives us the Ford itself. And what if we do this? What will we have? It doesn't return anything. If it returns the element, if it exists, none. If not, that means it's not going to return anything. Compared to the other one that gave us error, this particular one will not give us anything when it comes to get. So if it's, remember what you stated here, it returns the element if it exists. But if it doesn't return anything, it doesn't show an error in your work. This will come very handy in your data set when you're trying to get some things. If it's not there, there's no need of spoiling your whole steps in your coding. It should just return none, and you definitely know that something is definitely this particular name is not there because it's not case sensitive. So length also give us the length of a dictionary. For example, the number of key value pairs. If you put in the length of a car here, it's going to return 7. If you check the length of this particular dictionary, you can see that they were actually 7. 1, 2, 3, 4, 5, 6, 7. Okay, that's how it is, and that's how you get the length of a dictionary. And also, if you want to check the length of the number underscore names, which you have done before now, you can see that it was from 1 to 8, which is actually true. Now, the next thing we're going to do is the in operator. We have used the in before now. We have used
Hello,
the
sorry,
in
please.
before. Okay, yes. Mr. Sunday, please ask your question.
What's the difference between pop and get? I'm just trying to see. Is there
Pop,
any difference between them and get?
pop, like
Yes,
POP.
yes,
Pop
yes.
is pop is to delete now, to remove an element from a dictionary or list and store it in a value in case you maybe put it in a variable. That's the difference. Get get is just to, like, okay, maybe I want to get something from maybe I want to get a particular element, a particular value in a dictionary. I can call out the what they call it, the key of that particular value that we want to get, and we'll just get it to come out to return the value. But pop is to
Okay,
delete. Pop removes things from the dictionary.
okay. It will not change the initial
No,
dictionary.
get does not change anything in the dictionary.
Okay, okay.
Get
Thank
does
you.
not change anything. Yes, thank you. Okay. Let's confirm this. So we want to use the in operator in dictionary. It's going to be very, very handy as well. I think I've used this several in my work as here. Is especially when it comes to dictionary. Remember, I told you that dictionary can also always convert them to data frames. When we get there, you can. I remember asking me what is data frame. Don't worry, we'll get there. It's more of like the way it's being stored. Data is being stored in a frame. Like for example, that's rows and columns, and you can actually access each of them over there. So we go straight to in operators, and we say age in cars, and we can see if in this car, you can see there was what we call age, and it definitely is going to return the true operator. It's going to return a Boolean value of true. His height in car, it was definitely not there, so it's going to return false. And how can we also say, okay, what of in the keys alone? Maybe we want to access only in keys. Okay, height in car dot keys is still going to return false. Okay, so it is also to check the value as well. We can also check the values. These are ones for number underscore names that we have defined from 1 to 8. So 6 in number underscore names dot values. Yes, it is true. Okay, so the next thing we want to do is see what I just did here is quite different. Value to check. So I define a variable name value to underscore two underscore check to Mustang. I just Mustang and I just put it as a string there. So instead of just putting Mustang in car dot values, I decided to now say, okay, values underscore check itself, which I've defined as a variable here in cars dot values, which is going to return true because definitely Mustang is actually there. It's actually there in what? In values. Okay, so the system battery is getting low, but nevertheless, we'll find a way to fix that up, or we can always continue in the next class. Okay, so let's just go straight to the same thing I did for Mendo here. I did it for Mondio. It's not there because it's not in cars. By the time you do it, it's going to return false is going to return false. So that's the same thing. That's what we did for Mustang here, and that's the one we have done for this. And this particular string does not exist in values. Is going to return false. So the next thing we're going to look at is how can we now look properly into a word? How can we look through a dictionary? The same thing I've been doing for list and the rest. How can we now look through a particular dictionary? So let's just go there and let's see how it's being done. So we can see different cars: Audi, Germany, Mazda, Japan, Fiat, Italy. I've done this before, and let's just continue. Remember when I told you that you make use of key items, keys, and values. And by the time you make this work, these are the things you can use to look through. You can see here for car in cars, mean that this particular car, remember these are dictionary now is cars, not car. So for car in car, I can well decide to use this place as I or anything. This one is just representing each of the elements in which I'm looping through each of the items. So how do I get it? Once I get this, I want to print car itself. So it's going to print each of them out as we have done before now, which is going to store them in a tuple. Remember when I told you it's going to store each of the pairs, the key value pairs in a tuple. You can see it's no longer like a column here. It's storing it as a tuple. So you can Audi, comma, Germany, all of them are in tuple. And tuple is like stores in a what? In a normal parenthesis that we know, the normal bracket that we know. So by the time we do that, we can make it work for us. So remember what we did before now, we can decide to say, okay, I can decide to put a string inside of it and say, okay, for brand, comma, country in cars dot items. Okay, this particular brand here is trying to represent the key, and this country here is representing the value of this particular dictionary, which is in what? In cars. Okay, so for brand, comma, country in cars dot items, and what are we going to print? We want you to print the brand itself. But as it's printing the brand, it should come with a dash here or an hyphen that shows that this particular place is also this side is country as well. I can decide to put column here or anything at all just to represent what I want to show. So by the time you print this out, it's going to give you what Audi dash Germany Mazda, just showing that it is actually what we want to show. Okay. The next thing also for keys, maybe we want to just print keys. So for K in cars dot keys, we print K, and K is going to return only the keys of that particular dictionary. The same thing with values.
I can't hear him again. Am I the only one?
No, I can't also hear him again. I think probably his battery is down. Dr. Payemi, please continue. Thank you. Mr. Sunday, kindly continue, sir.
Dr. Payemi.
Or Dr. Payemi, please continue. Or Mr. Sunday.
I can't continue.
Mr. Tosin is the
Okay.
chairman here.
Okay, what is going on? Who are taking over the chairmanship? Mr. Sunday. I'm here. I'm back here.
Okay, sir. Welcome back.
What was going on? Oh, please, who was taking in charge? Let the person continue. Everybody is quiet. What's going on? Oh?
No, we're waiting for you to take over.
Everyone got quiet.
So when the boss man is around, everybody will be.
Okay, I better go. All right, let's just see what we can continue doing. I think I just found a way out. So let's just let me continue sharing my screen as well. So I okay. So you can see it's actually quite simple enough, and I'm going to just give you guys a little something to do, and it's going to be just a little example. So can we define a function? Name count letters. It will count each letter in a text and print. You can see something like this. Uh, you can see something like this. More like A, 3S, 3E, and 1. Like at this particular A is for the key, and the value is 3. S here is the key, and the value is 3. E here is the value, the key, and the value is 1. So you can see here, and this is what to do. So by the time we say define a function, name count letter. So this is the first solution. You define a function and count underscore letters. You definitely are going to put a parameter which has an argument text. So a dict for numbers and count. So we can put the letters. Letter is equals to an empty dictionary. And okay, now guys, let's do this. Let me explain this for you guys. So please just look at the comments as well. So the first one is for what? We remember what the question is. Define a function name count letters. It will count each letter in a text and print. So it's quite what we want to do. Define. You can also try it in your own way, but I always want to always make my own something we can actually understand and see what we can make out of it. So we define an empty string, an empty list. Sorry, an empty dictionary, and we said for L in text, what is the text here? There is the text here we are going to put in. And for L in text, what are we going to do for that L in text? Okay. Check if L is alphanumeric. What does it mean to be alphanumeric? Guys, what does it mean to be alphanumeric? Anything? Someone could just search Google now. What does it mean to be alphanumeric? It's very important.
Has both alphabet and
Mr. Tosin, I can't really hear you.
has both alphabet and numbers.
Alphabet and numbers. Okay. Any other person? Okay. So someone wants to say something.
That's what I wanted to say. Like it's made
What?
up of alpha. It's made up of both alphabet and number.
Okay. Okay. We'll confirm that as well. Okay. So let's continue. Okay. So if L dot is alpha, that means if that particular thing is actually is alpha, what are we going to do? We're going to do what? Check if this letter is already in the what in the dictionary. So if that letter is already in the dictionary, we're going to add it to that particular dictionary. So you can see if L in letters dot keys. So what are we going to do? If that letter is already in the dictionary, we're going to do what? If L in letters dot keys, letter, which is the L itself, will be what added to this particular word. It will be what added to this particular word dictionary that we have. Okay. So for the first time, that is the first time. So first time else, that letter L is going to be equals to what? Is going to be equals to what? 1. But if it already exists, this thing, if it already exists, you have to do what? You have to say, okay, L is what equals to 1. So this is what I'm trying to make it a whole lot of sense here. So the first one is L dot is alpha. Check if this letter is already in the it. So if L in letters dot keys, okay, letters, that particular letter that we have, L plus equals to what? 1 is trying to do what? Check if this particular one is if it's not there, we are going to what? Add it to the what? To this particular dictionary. But if it is there already, you already leave it, you're going to leave it as letters L equals to 1. And when you do that, you're going to return what? Letters. So let's just see how we we're going to put it. Let me show you a practical example here, and let's see how we make it happen. So let me make it work. So I don't know if you can see the output here, guys. This it looks smaller. So the text here is what we are going to put here. The text is example one. We're looking at the counting of this particular what numbers here. So by the time we say text equals to example text, letters equals to, now these particular letters in which we have put here, the letters, which is an empty dictionary here, is what we are passing here. And what are we passing here? The letters equals to count underscore letters, which is the name of the function here, count underscore letters. And we are putting the text itself, which is example text. So by the time we call out letters here, it's going to return, uh, E, which shows what 3 times here, is going to return it as what 3. You can see this was the function of what this particular word. If L in letters dot keys is going to add it. Going to continue adding it plus one until it gets to a particular word, until it stops at that particular word number in which contains the text itself. So you can see here, by the time we say E will return just what 3, X will return 2 because there are 2 X's here. A will return 1, M will return 1. So exactly what we did here, if L in letters. So if L in letters dot keys, okay. So if it does that, that particular letters is going to do what? We add what? Plus equals to what? 1. So the number of time is going to do what? Loop through the number of occurrence that is inside this particular L is what is going to come out here in this. The main line here is this if L in letters dot keys. Letters L is going to be plus or equals to what? 1 is adding to it. But if it just the first time, that's the very first time is going to be what? 1 is going to be what? 1. That means the initial, just like saying summation is equals to 0. But this particular one, the first time is going to start from 1 instead of 0. It's starting from 1. So anything that we have here is going to add to what? To this particular letters to be what? 1. I don't know if you understand what is happening here. Please, if you do not understand, let me know. So I will go back to it and explain. So what he's trying to say that initially what the letters count is dot alpha is trying to tell you that the initial state of it is going to give it as what? 1. But if there are more occurrence of that particular letters, is going to, if that letters in dot keys is going to increase it to what? The number of times that it actually exists in this dot is alpha. I don't know if you understand what I just said. Mr. Funso. Okay, Dr. Payemi, your hand is up.
Yes, doing it this way it will take more time for someone to actually just look at it before someone can understand. But alternatively, I want to ask, please let me
Okay.
see your screen.
Okay, sir.
Is it possible to also do it this way?
Okay.
Instead of, please go up.
Okay.
It's okay. It's okay. Instead of putting this test in this function bracket, can't we
Okay,
define
sir.
the test and then we'll do like this? Define count letters and then we'll put the bracket empty. And then the next thing will be test equals to, we'll now list out those example tests. Is it not possible to still do it like that?
Without that means you don't want to use function.
No, you were still using function. We'll do define count letters and then we'll leave the function bracket empty and then define the text separately immediately after, like test equals to, then we'll list out those example tests we used.
Okay, let's work on with that what you said. Let's see. Let me go back to, okay, this is where we are. So let's see what you want to do. So what did he say? Let's see practically.
So I said remove the test from the function bracket and define it separately.
Okay.
Just
So I
go up.
copy. Let me just
Remove this
copy this,
test.
right?
Yes. Yes.
Okay.
You can just
Copy. Then let's test it here. So what do you say we should do here?
okay. So I said remove this test from that bracket. Delete it from that bracket.
Okay. Okay.
Okay. Then click enter, like enter.
Okay.
After the colon, enter ahead. Then test equals to
Okay.
test equals to. Then those example tests will list it out directly.
Okay. Let's
Again,
okay, yeah.
those example tests, yes, we list it out
Okay.
completely, not like this. Like we list
Like
them
this,
out
right?
exactly the way it is, the way it is in the question.
Like
No, the
this,
way it
right?
is in the question. No. The way it is in the
Okay.
question. Go back
Like
to the
this.
question. The test. Yes.
Okay.
Yes. The way it
Okay,
is in the
like this.
question, we'll list it out. Yes, you just
Okay.
copy that and put.
Okay. I think like
Test
this.
equals to. No. Test equals to. That's where you paste it, instead of example test. You paste out the
Okay,
test
sorry.
exactly the way.
Sorry.
Yes.
Sorry. Yeah, right?
Yes.
Okay.
Yes. Then every other thing
Okay.
can continue exactly the way it is. Every other thing can remain the way it is. Like this.
Okay.
Can't we do it
Okay.
this way?
This
That's what
this
I'm
is
asking.
this is the answer. This is what you are that this thing that you are doing now is the answer we are looking for.
Okay,
The
is it
reason, yes.
okay? Okay,
So
okay, okay.
whatever
I
you are doing
understand.
for is the answer. So the is alpha is saying
Okay,
just to
okay,
count.
okay, okay,
Yes.
okay,
Yes. So that's the
okay.
answer.
Count,
This, yeah.
count.
Yes, that's the function of is
Okay,
alpha too, and this is alpha is doing that function, that particular
okay,
work as
okay,
well.
okay, okay.
Yes, that's
I get
why
it.
it's yeah. So that's the reason for this particular all these things that we're
Yes,
doing.
I get it now. I
Yeah.
get it now. Sorry for the
Okay. So let me
distraction.
just it's not distraction. We are learning. It's very important that you. It's very very important. So these are the things that we get. Okay, Mr. Sunday, your hand is up.
Hello, thank you. Please, can you
Okay.
go back to the code?
Okay, I'm back to the code, sir.
So I have, I don't know, I just have some number of questions here.
Okay, let's first of all let's go to what is alpha does.
Hey, that's one. The first question I want to ask.
Let's Google
It's
it
alpha.
alpha. Okay. So let's use the W3 school explanation of its alpha. So its alpha checks if all the characters, okay, don't worry, let's go. So its alpha method returns true if all the characters are alphabet letters A to Z. Example of characters that are not alphabet letters like space, and this will not do what? Will do not return as what parameters. So we can see here, for example, for a text here, which is company 10, x equals to txt dot is alpha. If you print this out, okay, it's going to return what? False. It means what? What does it mean? It means that this particular this thing contains what other numbers as well. So its alpha method returns true if all the characters are alphabet letters. So what you guys were saying at particular time was actually kind of not correct as well. So its alpha does what? Returns what? A particular what they call it, alphabet, the number of occurrence if the word, that particular word alphabet does what exists. So you can see here is alpha dot method, which is being used by W school, 3 schools here. You can also try it yourself. So you can see here company X is equals what? True. So it's actually what? First of all, we have seen that is alpha returns only what? Alphabet letters, not just numbers. Alphabet letters. So you can see here, when it actually, that was a very nice one from Google. So at some point, let's see. So you can see here, if it's alphanumeric, it's alpha. But what I know is is alpha that I use so far is actually is alpha normally counts for me. It actually counts the number of occurrence for me. But let's see, apart from W3 schools, let's check other ones that we actually know. What I use is alpha is just to is actually to count. Man, I use it to count if it's a particular thing is true. I use to count the number of characters in a particular uh, what they call it Python code. Let me look at let's see. Let me just use this alpha, what they call it in Python. So Python string is alpha method is a built-in method used for string handling. The is alpha method returns true if all the characters in the strings are alphabet. Otherwise, it returns false. The function is used to check if the argument includes only alphabet characters mentioned below. So let's use gigs for gigs and let's see how it works for gigs for gigs. Okay. So these are examples that we are using strings.alpha. Most especially me, I use mine for counting. So I think I've used this before in the previous classes. So you can see here string is equals to Ayush is going to return true, but once it gives this there's 212 is going to return false as well. So you can see a practical examples here: true, false, and true, false, false. Okay, okay. Okay, okay, this is a practical example of what we are doing. This is something that we are doing right now. So Python program to illustrate counting number of alphabets using, I don't know if you can see my screen right now. Mr. Sunday, please, can you see my screen?
Yes, I can.
Okay. So if you look at this, this is a practical example of what we are doing. So you can see initializing new strings. New strings one, there's an empty string. Is an other empty string as well. So what we want to do is for a in a string, in this particular string that we have, which is Ayush Zazena, we are setting the initial count to what to be 0. So by the time we do that, and for a in string, if a dot is alpha equals true, that means if it contains just text letters, that's alphabet, what are you going to do? You are going to make that count plus equals to 1. And by the time you say count plus equals to 1, you are going to add that the particular a that is inside this string into the new string that we have put here, which is new string 1 equals to an empty string. So by the time you do that, you're going to fix it up here and you print the count and you print this particular word new string. By the time you do that, it's supposed to give you the number of counts for this particular letters that we want to do, like a particular alphabet, that how many the numbers is going to give you as what 11. Exactly what we wanted here for the very print count as well. So you can see count started with plus or plus equals to 1. That's the count itself. I don't know if you understand the whole concept of Mr. Sunday. Please, do you understand the whole concept here?
Oh, okay.
That okay is not sounding okay.
No, sir, I don't understand it.
Okay,
Be-
it's really okay.
But I'll go through the video again. Maybe
No,
later
no, no.
tomorrow.
See, let's see this. No, we are not. We have to find a way out. So see, look at this very well. we have found out that there was an error here. The first error we did was we thought that since it's we thought it's alphanumeric, that means it contains numbers and alphabets. No, it's alpha actually text. But what I normally use is always like I use it for counting. I've never for once said, okay, because of one of our the data that we always use are always string characters. So I always use it as for my string characters, not knowing that it has numbers as well. So we can see something that I've also equally learned that it's also for numbers as well, for alphabets alone. So we can see here, let's go to the dictionary itself. We count the letters first and we put a text. So a dictionary, we are defining an empty dictionary here, which is what letters. Almost the same thing as what we did here for gigs for gigs. These particular guys have decided to define an empty string, which is new strings equals to an empty string. And let me go back to the dictionary itself. What happened? Okay, the dictionary. So we can see here for L in text, that means we have not brought out the text yet, but we are already looping inside this text. Okay, so for L in text, we're going to say now inside that text, check if it is alphabet alone, if it's alphanumeric itself, if it is going to use the method alpha. So if L dot is alpha, that means inside that text, if it only contains alphabet, this is what I want you to do. Okay. So what you are going to do is check if this letter is already in the dict. So if that particular letter is already inside this particular dictionary, which is going to be what E, which the text we are using there is example text. So if this particular letter is inside the dictionary already, we are going to do what? We are going to say, okay, add to the existence of it, which is going to be in the count here. Letters L that is already inside the dictionary, add to the existence of it in terms of counting. So if inside this dictionary there was E already here, so if it already is E is there, originally else already tells you that the count already is 1. So if it exists again and it's inside the dictionary, there's another occurrence using the is alpha, please, I want you to add what? 1 to, I want you to keep on adding 1 to it. So by the time it reaches its number, it's going to say, okay, if there are 3 E's, it's going to return +1, +1, +1, which is going to be what? 3. I don't know if you get it now. It's going to return +1, +1, +1 equals to 3. But if, okay, let me try to do something here. Let me run this. It's connected. So let me run this and let's see. Instead of putting 1, let me put 2. Okay, instead of putting 1, let me put 2. And you can see that E here is 3. So if I put 2 here now, what do you think the occurrence of E will be? When the initial of letters is 1, what do you think the occurrence of E will now be? Instead of it to be 3, what do you think it will be? It's going to be 4. Let's confirm that if it's going to be 4. So we run this and we call this out and we run it again. Let's see. So we call the letters itself. So the occurrence of E is what? 5. Why is it 5? Do you know why it's 5? Because the very first occurrence that we have for E was 1. I don't know if you get it. So the very first occurrence of E was 1. So there are 3 E's. So 1 plus 2 plus 2 will give us 5. Mr. Sunday, please, let's get this. If this way we are going to get stuck, let's find a way out of this. Mr. Sunday, do you understand?
Yes,
Do you understand?
I'm looking at the letters, like the keys. So there's no append. But I understand the looping process now. I
Okay.
added it, then the way it continued to iterate and add concatenating of it. Then I'm just looking at how we call out the function, then how the letter it was able to append inside that empty dictionary. So that is what I'm just looking at now. Like the way it append inside that dictionary, because we didn't use any append or anything.
That's
so
the function.
I'm just like
That's why I told you that's the function of the keys, the items, and the values.
okay.
So that's what it's trying to tell you, that as it is looping, it's automatically, this is dictionary. This is definitely dictionary. Okay? So this is the dictionary. Even when these guys were explaining gigs for gigs, was there any append here? There was no append here. There was no append here at all. So that's a function of the what they call it. You're going through a dictionary. You're going through a dictionary. Okay, I am looping through the dictionary. That L already that I have appended, that I've already used as a text. That text that I've used inside that particular text. Okay, I'm putting L. L represent each of the alphabets in that particular text. Okay, so as it's going through this thing, the keys itself is coming, okay, this is what I want you to do. Now, when we're doing this, let me go back to our code. Sorry. Let me go back to our code. When we're doing this, let's go back to our code. When we're doing this, Mr. Sunday, did we add any append to this? We did not add any append.
No.
There was no append to this at all. So we just defined, we call out the dictionary name, we add 1 to it equals to 1. We did not say append this, append this. No, it did not. That doesn't work for list, for dictionary. So you can see here, it goes straight to the dictionary itself and said, okay, it's an empty dictionary already. Okay, let me just populate it at once for me. But I hope you understand. So even that, if I put these letters to be, let's say if I put these letters to be 2, now what will be the value of E now? Instead of 5, what would you think the value of E would be? Everybody can put the answer in the chat box. What do you think the value of E will be if I change it to, if I change the initial one to be 2? Anybody typing? What do you think the value of E and other letters that are having the occurrence would be? It's going to be 6. Mr. Sunday is going to be 6. That means you actually understand. Let's confirm if that's true. The only mistake we did in this code was the alphanumeric issue, when we thought that it is when the answers came in as letters and numbers, which is not true. It's only for letters as only. So you can see, if we run this now, you can see other letters that have 1 occurrence turns to 2. E now is 6. The other one that has, you can see T here, T should be 2. That's why it's 4. You can see here, in T, we have 2 T's here, and X here is also 2. That's why it's 4 here. So that's how it's being done. We return letters. By the time we return these letters, it does this particular work for us. So I think that's where we will stop. That's where we'll stop. And we could have also done the same thing here, but this one is complex enough for you guys at this stage, but I will still do it in the next class. But I hope you understand this concept. We're able to find a way out, right?
Please, I would like to ask, when are we getting this, what's it called? The code, the material.
And the material
Like
will be
this
available
present
before
code.
the materials will be available immediately. Once I send the material, that's when we'll be having maybe I'll be sending questions for you guys to solve as well.
Please, what material?
Okay.
This particular material we are looking at.
Okay, okay, okay.
All right, thank you guys. Thank you for joining in, and that will be all. For any questions, if you have any questions, please don't stop to ask. And some persons have not submitted their work, and if you have not submitted and maybe you have given an excuse, there's no problem. Just find a way and submit it before the time you said you will. And some persons have not even replied about the whole assignment. Something. It's very important that you actually do what you're doing when it comes to coding. I used to tell people you just have to. I cannot guarantee you anything when it comes to if you have not been doing your coding as well. So you have to put hands on, try as much as possible. As you are doing it, you get to discover new things. For example, now we have discovered what is alpha, what it does exactly in and so far. So we can see a whole lot of things. Always let's try as much as possible to always do the hands-on itself. We always try to do the hands-on ourselves. It's very, very important. Hands-on is very important. You see, you encounter problems and you solve it, and you'll be so happy that you actually did that for yourself. Okay, so thank you guys for joining in, and that'll be all for tonight. The recordings will be available shortly.